Today I was using this little hot glue gun right here to put together a couple toothbrushes, and this makes me wonder. This hot glue gun, it has the cable over there, which of course leads to a mains plug, North American mains plug. But I mean, there is no sort of indicator for when this hot glue gun is actually on. I mean, this thing is supposedly UL listed, but it doesn't even have a little indicator telling you that it's on. I mean, well, to be honest, if it's plugged in, that should be a good enough indication that it's on. But I mean, it's just it doesn't really make any sense. Like, I mean, you want some sort of indication to know that it's on. So today I want to change that with some neon indicators. And I have used these things before, just for example, for just playing around with a Tesla coil or indicating the high voltage output of a taser. But this will be the first time that I actually use my little neon indicators over here. Get that thing out of there. This will be the first time that I actually use my neon indicators for the purpose that they're actually designed for. So let's go ahead and take this thing apart. So that's that. All 5 of these Phillips screws are removed, and now we can pop this thing open. So it looks like over here we have, of course, the trigger mechanism, which pushes the glue stick into the furnace. I guess that's what you'd call it. And of course it melts the glue and extrudes it out the tip over there. And this trigger mechanism can come off. It does seem a little bit delicate, but I mean, you just have to put the trigger right there, and then it'll still compress like normal. So I think we can remove this temporarily and just hope this doesn't come apart any more than it already does. Well, I mean, it's got this little linkage over there has some little pins in it, so we shouldn't be too worried about that. But anyway, now we need to pick a spot where we can put this neon indicator. I kind of really want to put it on the same side as all the rest of the parts are mounted on, because just having it on this side will kind of be an ordeal. So I'm just going to go ahead and drill a hole right there. And of course, because I do not like big scary power tool, I am going to use my hand-powered drill. It's kind of annoying, and it doesn't really work very fast, but it gets the job done, and that's really all I care about. Alright, so the hole has been drilled, and the indicator fits snugly and sticks out a little bit. It's really not the best that it sticks out. Of course, this little stem can be broken, but you know what? I mean, I don't really have a proper cover for this sort of neon indicator or a proper way to mount it. And I guess the diameter of this little glass shell is just perfect for whatever the diameter of this drill is. And in fact, I can probably see what this says. Apparently it's 3/16 of an inch. I have no idea how much that is in millimeters, but I guess you can do it yourself. But anyway, the thing is, these neon indicators do not like being connected to mains because they will blow up. So it is going to be necessary that I have some sort of current limiting in series, and for that I am going to need a resistor, and it will take me a while to calculate the value of the resistor for this specific sort of application, so I'm going to pause. All right, so I have done the appropriate calculations, and as it turns out, I will need a 100 kilo ohm resistor to safely run this neon indicator. And by appropriate calculations, I mean that I watched a Technology Connections video. So let's go ahead and get to putting this thing together. Yeah, I forgot to turn on the soldering iron. This will take a while. But never fear. I can fix this, or at least prepare this for use, so that I have some place to tap off the wires from. And to do this, I will disconnect and reconnect the wires. Come on, you gotta be kidding me. Yeah, well, you're gonna understand what I'm doing. So the soldering iron has warmed up, and I have inserted the neon indicator and cut one of the leads, so now I can stick that resistor right there. So that's hooked up nicely. And I did make a slight blunder due to some errors in the stripping process. This wire is now significantly shorter than what it's supposed to be, and also this wire's insulation is a bit damaged, so this is definitely not UL listed anymore. But anyway, I can realign this wire and this resistor over here so that they will connect a bit better. I don't know if you can see that. Alright, so everything is connected back up. Even the triggering mechanism somehow still seems to be able to work, even with all this junk in the way. So let's just make absolute sure that those wires do not touch. And now that was a complete disaster, because now I'm going to have to resolder a connection. Alright, so everything is all hooked up. Now the question is whether or not the trigger mechanism will fit in here. So this little push ring goes on top of the glue stick, and it goes into that little slot. The trigger piece goes into that little socket, and this spring hooks onto that clip over there. So, yeah, I would say that this at least seems to me to be able to work. Well, at least, well, I mean, it's going to work better when I actually put the top cover on it and try this out for real. So let's go ahead and start adding these screws back. First and most importantly, this one, because the strain relief section of the cable has moved a bit, and this screw is what initially crushes down on the cable, the mains input cable, to create the strain relief. And so, sorry there. So that is most important for helping keep this thing together. And maybe a couple other screws too. Let's pause. One thing that I should mention when you're putting screws like this, which tap directly into the plastic, it's important that when you put it in and you start screwing, you first screw it counterclockwise until you kind of hear it click, kind of like that, and then you twist it clockwise like you normally would. This is because the screws have already carved a thread into the plastic, and doing it the way that I just told you keeps that original thread instead of cutting a new thread and destroying the screw base. So anyway, that is the hot glue gun all put back together, and of course the little neon indicator is sticking out over there. And in fact, that little stem looks quite the stem looks like it's sticking out a little bit. It would be nice if this was a little bit shorter, so let's go ahead and But anyway, one thing that I'm going to have to do before putting this thing back together entirely is check the resistance of this plug just to make sure that I didn't really short anything out. It is set to the 200 kilo ohm range. And just in case you're wondering, yes, I do have a better multimeter, but this one is just a bit more available to me at the moment. And it looks like that we have a resistance of 1.3 kilo ohms, which is probably just the resistance of the PTC element in there, and it doesn't really have anything to do with anything else that's in there. So let's go ahead and plug this thing in and see if it explodes. To play it safe, I have decided to do this on the floor, away from all the rest of all that cardboard and gunk. So that way, if I plug this in, it won't immediately, and if it explodes, it won't immediately, like, catch fire or something. So anyway, I'm going to stand a little bit away from this and plug this in and see what it does. Would you look at that? It lights up. How nice. Yeah, would you look at that? It's clearly glowing in the presence of that of the mains power. So yeah, this was a decent success, I have to say.